Hi, hoping a pleasant full day to everyone. This is Brahmanapalli Sucharitha, first B.Tech Computer Science and Engineering from JNTUA. Today we are going to discuss a topic from data structures, and the topic is most known sorting technique, that is quicksort. Now let us go with an overview. Here we can see define, algorithm, logic, brief example, complexity of quicksort, source code, characteristics of quicksort, analysis of quicksort, and applications. Starting from define of quicksort. Quicksort is an efficient sorting technique. It works by the principle divide and conquer. So, it is also called as partition exchange sort. It works by selecting a pivot element from the array and partitioning the other elements into two subarrays according to whether they are less than or greater than the pivot element. Now, observe the element 70 is considered as the pivot element from the list, and the remaining elements are classified based on the condition less than greater than 70 into two subarrays. Moving to algorithm of quicksort. Firstly, we have to consider an element as a pivot element from the list. Now define two variables I and j. Then set I and j to first and last elements of list respectively. Later increment I until list of I greater than pivot, decrement j until list of j less than pivot. If the condition I less than j satisfies, then exchange list of I and list of j elements. Repeats the steps incrementation of I, decrementation of j, and exchanging the elements list of I and list of j if condition satisfies. Finally, to acquire output, exchange the pivot element with list of j element. Moving to logic of quicksort. Here in this we use recursion function, if condition, while condition. Have a keen observation towards the logic of quicksort. A brief example for a quicksort. Here we consider 54 as pivot element. Now left mark and right mark will converge on split point. Here 26 less than 54, move to right. 93 greater than 54. Now stop. Right mark 20 less than 54. So right mark, stop. Now exchange the elements 20 and 93. Here continue moving left mark and right mark. Since 77 greater than 54, 44 less than 54, exchange the elements 77 and 44. Now 77 greater than 54 and 31 less than 54. That is right mark less than left mark. So the split point found. Exchange 54 and 31. Now 54 is in place. Now observe quick sort left half and quick sort right half. Going to another example of quicksort. Here the element 3 is considered as the pivot element, and the remaining elements are verifying based on the condition less than or greater than. If the condition satisfies, the elements are exchanged. Now the element 1 is considered as the pivot element to the list. Now element 2 act as pivot element. Now element 4 act as pivot element to the list whether the condition satisfies they are exchanged. Now the element 6 act as pivot element to list. Now the element 5 is pivot element to the list. Finally, the element 8 is pivot element to the list. Finally, we get an sorted output. Now have a keen observation towards the graphical representation of quicksort. Now a T diagram example of quicksort. Moving to next topic, complexity of quicksort. Here, in the worst case performance, it is n squared 2. In best case performance, it is n log n. And also in the average case performance, it is n log n. Finally, coming to worst case space complexity, it is n. The source code of Quicksort. Have a keen observation towards the source code. These are the output of the source code with the given input. Now, analysis of Quicksort. The total running time of the Quicksort function is going to be the summation of the time taken by the partition and two recursive calls to itself. Characteristics of Quicksort. Quicksort is useful for sorting arrays. The space complexity of Quicksort is n log n. Finally, the applications of Quicksort. Quicksort is used everywhere where a stable sort is not needed. Variants of Quicksort are used to separate the kth smallest or largest elements. Quicksort's divide and conquer enables the usage of parallelization. Quicksort is a case-friendly sorting algorithm as it has good locality of reference when used for arrays. Quicksort is a tail recursive and hence all tail call optimizations can be done. Quicksort is an in-place sort that it does not require any extra storage. Thank you.